Good morning dear students. So far we are discussing about the D block elements. Today we are going to discuss about the important compounds of D block elements. First of all, we are going to discuss about the oxides. Transition elements combine with the molecular oxygen to form an oxide except scandium. Scandium cannot form oxides with the molecular oxygen. So the oxide formation, the oxidation number in between the +2 to +7. Okay. The lower oxidation states are ionic oxides. Ionic oxides. Oxidation number increases, the ionic character decreases. So, the higher oxidation mostly covalent oxides. The same way, the lower oxidation state oxides are basic or amphoteric in nature. Amphoteric in nature. Whereas the oxides of higher oxidation is acidic in nature. For example, we can say CRO, lower oxidation state oxide, this is chromium oxide, is basic in nature, whereas Cr2O3, chromium trioxide, is amphoteric in nature. Here we can write H2, Cr2O4, this is acidic in nature. What's the difference? The oxides of lower oxidation state are ionic oxide, they too basic or amphoteric in nature. The oxides of lower oxidation state are ionic oxides and the basic or amphoteric in nature. The oxides of higher oxidation, they are least ionic or otherwise covalent oxide and they are acidic in nature. Okay. Then let us move on to the very important compound of transition element, potassium dichromate, that we are going to see now. K2Cr2O7, potassium dichromate. Okay. Preparation. It is prepared from the chrome ore or chromate ore. Chrome ore or chromate ore. Not the same. That is the formula FeCrO4. This can be written like this, FeOCr2O3. Both are same. In some book they will give like this, in some book they will give. It is a chrome or chromate ore. See, looking this, the chrome ore or chromate ore is a oxide ore. The first step of preparation, we are going to see the concentration of ore. We can concentrate this ore by using gravity separation. Gravity separation. You know very well what is the gravity separation. Gravity separation is the ore is mounted, the stream of water is poured. Then by using the gravity we can collect this. This already we have discussed in the metallurgical portion. Gravity separation. So the chrome ore concentrated by gravity separation. After that concentrated ore is going some chemical process. These are very important 5 mark question in state board level. You have to keenly watch the chemical preparation of potassium dichromate, that we are going to see now. In first step, we are taking chrome ore, four times of chromate ore plus 8 times of sodium carbonate, Na2CO3 plus 7 times of oxygen. If you take this to 900 to 1000 degrees Celsius. the temperature, what happened to the chrome ore? Chrome ore will become a sodium chromate. Chrome ore will become a sodium chromate plus iron oxide plus carbon dioxide. While seeing the balancing equation, 8 times of sodium chromate and 2 times of iron oxide and 8 times of carbon dioxide. So this, by looking at a large equation, you can easily memorize 4, 8, 7, 8, 2, 8. Okay. That is the first we are converting chromate ore into sodium chromate. Again, second step. Sodium chromate is treated with a sulfuric acid. You are treating with the sodium chromate with a sulfuric acid. There you are getting that sodium dichromate. Sodium dichromate. The second step, you are getting a sodium dichromate from the sulfuric acid. After that, in third step, the sodium dichromate is treated with 2 times of KCl, potassium chloride. There you are getting the potassium dichromate, K2Cr2O7, okay, plus 2NaC. So these are way how you are getting the potassium dichromate. Chrome ore is treated with a sodium carbonate and oxygen is heating up to the temperature nearly 900 to 1000 degrees Celsius. There you are getting the sodium chromate. Chrome ore becomes sodium chromate. That is first step. Then sodium chromate is treated with a sulfuric acid. You are getting the sodium dichromate. After that, sodium dichromate is treated with a KCl, potassium chloride. We are getting the potassium dichromate. This is our major product. Potassium dichromate. This is the way how we are preparing. This is a very important question in state board level. Write the preparation of potassium dichromate in a 5 mark. Many times asked, repeatedly asked question. So go with the equations. Okay, then we are move on to the physical properties of the potassium dichromate. Physical property. It is a red-orange solid, crystalline solid. Red-orange solid. Less soluble in a cold water. More soluble or readily soluble in a hot condition. When it is decomposed, while heating, it will giving a chromate ion. This is while heating, it will give a chromate ion and a Cr2O3, chromic oxide, plus 3O2 upon heating. Okay, upon heating, this is giving a chromate ion. Okay, this is dichromate ion. So ionic form you can write as Cr2O7 2 minus dichromate ion. This is a chromate ion. Okay, chromate ion. See, You have to balance. It's not balanced. 4K2 if you put, it will be balanced. 4K2Cr2O 8 times. Here only 4. So here 2. It will be balanced. Balanced equation. Always inorganic equation must be balanced properly. This is a major product you write, then you are getting into the balanced. If you see, it is a balanced equation. So while it is heating, it is giving a chromate ion. So what are the difference between the dichromate ion and the chromate ion that we are going to see now? Okay. This is a chromate ion. Cr2O7 2 minus dichromate ion. Okay. Both are sp3 hybridized. So tetrahedral in shape. The structure, if you see, both are sp3 and tetrahedral in shape. If you draw the structure of these, Cr, O, there is a tetrahedral in shape. So the partially double bond character arises. So I am putting like this. Two minus partial double bond character is there. Okay. So here there are bond length is 166 picometer. There are 4 CRO bond. How many CRO bond are there? 4. All are equivalent. In a chromate ion, there are 4 CRO bond is there. All are equivalent. Okay. What about the dichromate ion? Same way, double tetrahedron, that is CrO. This is also sp3 hybridized, no worry at all. Then minus partial double bond character. These are like this. What is the difference here? Here also 163 to 6. In some book they are given 163. In some book, if you go to the 63 picometer. And this bond length, this CRO bond length, the bridging CRO bond length is 179 picometer. That is the difference. So see how many CRO bonds are there in a dichromate ion. 1, 2, 3, 4, 5, 6, 7, 8. So totally 8 CRO bond. Okay, 8 CRO bond. Among them 6 are equivalent. 6 are equivalent. These 1, 2, 3, 4, 5, 6 are equivalent CRO bonds. The bridging CRO bond, these two only having the, it is not equivalent to that all. Here in chromate ion, all are equivalent. But it is not so in the case of dichromate ion. Here only 6 are equivalent. These two, 1, 2. These two is not are equivalent. That is, the bond length is 179 picometer. These are the structure of the chromate ion and the dichromate. Okay. Then the predominant. The existence are the predominant that we can write like this for both chromate and dichromate ion. In aqueous medium, CrO4 2 minus chromate ion. In aqueous medium, both are interconvertible. Both are interconvertible. That means in aqueous form, both can be interchanges. Potassium dichromate can be converted to potassium chromate. Potassium chromate can be converted to potassium dichromate. Potassium dichromate can be converted to potassium chromate. That is the interconvertible. in acidic medium. In acidic medium, dichromate ion is predominant. Acidic medium, dichromate ion is predominant. That means in acidic medium the existence more chances for a dichromate ion. In basic medium, chromate ion. So always in acidic medium you may find that a dichromate predominancy. In a basic medium, alkali or basic medium, chromate ion is predominant. So we can say in aqueous phase both are interconvertible. In acidic medium, potassium dichromate ion is a predominant. In a basic medium, chromate ion is a predominant. Okay, that's all about the physical and properties and structure of the potassium chromate ion and dichromate ion. Now let us move on to the chemical property. Chemical properties. Chemical properties. Oxidation. As you know very well, potassium dichromate is a powerful or strong oxidizing agent. Before that, you should know that what is the oxidizing agent. The substance or compound one who is readily undergoing reduction, they can act as a powerful oxidizing agent. Now I am saying this potassium dichromate is a powerful oxidizing agent. Why? Because it can easily undergo the reduction. One who readily undergo the reduction or one who easily reduces, they can act as a good oxidizing agent. See, look at the ion. Hereafter, all the equation in the form of ionic form. You cannot find a K, only ionic form. Potassium dichromate, we can write a Cr2O7 2 minus the ionic form of potassium dichromate. And it is an acidic medium. The H plus, what is the 4H plus are you are writing here? It's an acidic medium, sulfuric acid. For a full form sulfuric acid ionic form, we will write only H plus. Potassium dichromate ionic form, we are only writing the Cr2O7 2 minus plus 6 electron. It will give a 2Cr3 plus 7 H2 more. In your book, the 2 is found missing, printing mistake. 2 will not be 2 in your book. You add this. Okay. What is happening, sir? How it is undergoing? See, the oxidation state of chromium is plus 6 here. That you know very well how to find the oxidation state. For example, you want to find the oxidation state. For chromium, you keep the chromium as a X, unknown X. 2 chromium are 2X. Plus, for oxygen, we can put minus 2. How many oxygens are there? 7 oxygens are there. So equate to not neutral compound means 0, the ionic forming, what is the charges present? You have to equate this, minus 2. Then 2x equal to 12, x equal to plus 6. Always the oxidation state should be given as sign, plus 6. See, we not calculate this is only plus 3. What happened? Plus 6 to plus 3. It is accepting 6 electron. 1 chromium for 3 or 2 chromium 6 electron, and it is giving a plus 3 oxidation state. Now look at the plus 6 oxidation to the plus 3 oxidation state. It is easily getting reduced. Already I explained to you one who can act as a oxidizing agent, one who easily reduces that can act as a oxidizing agent. Here chromium is reduced to plus 6 oxidation to plus 3 oxidation state. Thus it is a powerful oxidizing agent. For the illustration of this oxidizing property, we have a lot of examples that we are going to see now one by one. First, it oxidizes Fe2 plus 2 Fe3 plus. Ferrous to ferric. It is converting ferrous to ferric, or potassium dichromate oxidize the ferrous to ferric ion. See how Cr2O7 2 minus plus 6 Fe2 plus plus 14 H plus. See, ferrous ion has the dichromate ion. And the potassium dichromate treated with the ferrous salt, the ferrous salt is reduced to ferric salt. See here, 2Cr3 plus plus 6 Fe3 plus plus 7 times of water. Okay. Second illustration for the oxidation property of potassium dichromate. Iodide to iodine. Iodide to iodine. It is converting iodide into iodine. For this Cr2O7 2 minus plus 6 iodide I minus plus 14 H plus. It gives 2Cr3 plus plus 3I2 plus 7H2. Solution 3. It oxidize sulfide to sulfur. S2 minus 2 sulfur. Sulfide ion to sulfur. So potassium dichromate ion Cr2O7 2 minus plus 3S2 minus sulfide ion plus 14 H plus. We are getting that 2Cr3 plus plus 3S 7H2. And equation number 4. It reduces stannous to stannic. SN2 plus 2, SN4 plus. Let's see how ferrous to ferric, stannous to stannic. The same way, Cr2O7 2 minus plus 3SN2 plus plus 14H plus. Getting that 2Cr3 plus plus 3SN 4 plus plus 7H2. And then sulfur dioxide into sulfate ion. So Cr2O7 2 minus plus 3SO4 SO2 plus 2H plus, giving you 2Cr3 plus plus 3SO4 2 minus plus H2. Okay. And finally, there are till more lot of examples are there. We can limiting this with alcohol to acid. It oxidizes alcohol. It's very familiar equation you have studied in 10th standard itself. Ethyl alcohol is oxidized to give an acetic acid. Since it's a strong oxidizing agent, we can write K2Cr2O7 potassium dichromate plus 3 times of ethyl alcohol plus 8 times of sulfuric acid. If you take, you are getting that 2 times K2SO4. No? The main process is 3 times of plus 11 times of water molecule will be there. The side product is there, that is not necessary to us. Can go through this. Here, what is the change? Potassium dichromate is oxidized ethyl alcohol into acetic acid. This is the main product. Okay. These are the illustration of the oxidizing property of potassium dichromate. Once again, if for looking these equations are too big, that is easy thing to recall and reproduce. If you go on memorize all those things, you cannot get it. The easy way to memorize all those equations, look at there. In all cases, potassium dichromate I have written, dichromate ion is written. Okay, in all those 5. This is a complete equation. Then 6 times of ferrous and 14 H plus for 4 equations uniformly, 14 H plus. All the, see, look at there, all dichromate anion will become you are getting the Cr3 plus in all cases, 2 Cr3 plus, 2 Cr3 plus, in all cases you are getting like this. Then all ion, your heading itself you are giving ferrous to ferric, Fe2 plus to Fe3 plus, iodide to iodine. See, before that for hydrogen, if you take a 14H plus, always you will get a 7H2. See, all the cases 7H2 till this 4 equations. And extra, this is a sulfur dioxide to sulfate ion, you are taking only 2H plus, that's why you are getting only H2. Okay, these are the illustration for the oxidizing property of potassium dichromate. And let us move on to the next property, very important property or important reaction, chemical reaction of the potassium dichromate is a chromyl chloride test. It is very, very important to identify the acid radical, especially chloride ion, in a qualitative analysis. See, take test tube, a little bit of the chloride salt. For example, I am taking initial chloride salt. Then you add a pinch of potassium dichromate, K2Cr2O7. Then you pour a few drops of concentrated sulfuric acid in a test tube. What happened after pouring the concentrated sulfuric acid? The red-orange fumes will come out, the poisonous gas. Red-orange fumes will come out. This is chromyl chloride. The red-orange gas is chromyl chloride. In the red-orange fumes, it's passed through the alkali solution. You pass this to the NaOH alkali solution. What will happen? You are getting that is sodium chromate. It is converted to yellow color solution, sodium chromate. The solution will become a sodium chromate. After this, you pour some amount of lead acetate. You are pouring here lead acetate, CH3COO twice. If you pour some amount of lead acetate, then you are getting yellow color precipitate. Yellow color precipitate. Yellow precipitate. That is, lead chromate will be formed. Lead chromate, yellow color precipitate. While doing the test, you are getting that yellow color precipitate mean there is a chloride radical is conformed. This confirmatory test to chloride radical anion, chloride anion, it can be calculated. So this is a practical view. What is the chemical equations for this? That we are going to write down. So potassium dichromate, K2Cr2O7, then chloride salt. I am taking NaCl, 4 times of NaCl, then sulfuric acid, H2SO4. Okay. I am going to get a 2 times of potassium sulfate, KHSO4, plus 4 times of sodium bisulfate, NaHSO4, plus chromyl chloride, CrO2Cl2, plus water. Okay, 2, 6, Here you have to take 6 times of sulfuric acid, then it will be balanced. So remaining 12 H's are there, 2, 6, and 2, 4, 6, so 3 H2. This is a complete balanced equation. Now you are getting that chromate chloride in first step. What is this? Here potassium dichromate is sodium chloride, that is a chloride salt, and sulfuric acid. Then you add this, you are getting this fumes. The fumes is a very major important product. That is chromate chloride. That fume is called a chromate chloride. Then you take the chromate chloride to what you are doing here, adding an alkali medium, that is NaOH. Or the fumes are passed through the vessel or test tube containing NaOH. What is going to happen? 4 times of NaOH if I am taking here. It is converting into the sodium chromate, Na2Cr2O4. Here, yellow solution, Na2Cr2O4, sodium chromate is observed, plus 2 NaCl, then 2H2. This also balanced equation, 2H2O. Right. Na2Cr2O4. Now we are converting the chromate chloride into sodium chromate. Further, this sodium chromate Na2Cr2O4 sodium chromate is passed over, or you pour little bit of lead acetate solution. Lead acetate. If we pour these two, we are getting lead chromate plus sodium acetate, CH3COO. This is a yellow precipitate. This is a yellow precipitate to get it. So once again I am explaining, this is very important chlorine test, 3 mark, 2 mark, 1 mark, many times asked in both as well as NEET and state board. You may find this equation. If you ask the equation 3 mark question, if what is the gases evolved, what is the color of the gases may be asked. These are the one word. What is the precipitate formed, what is the chemical element of the precipitate, they may ask. There are many questions asked based on the chromate chloride test. Chromate chloride test is nothing but it is used to find the acid radical, especially not all acid radical, only for chloride ion. This is a confirmatory test to find the chloride ion in a practical. So chemical reaction, when you add a potassium dichromate to that chloride salt and pour some few drops of concentrated sulfuric acid, you may get a potassium sulfate, sodium sulfate, potassium bisulfate, sodium bisulfate, and a chromate chloride. This is a red orange vapor gas, so it should be like this, simple red orange gas. This is called very poisonous to that. If you inhale for a few minutes, you may be faint. Sometimes it may cause death also. You are inhaling more amount of chromate chloride. So you have to be very careful in the laboratory while doing this test. Then the fumes of chromate chloride passed over to the alkali solution, NaOH. When NaOH, you passed over the NaOH, you are getting this sodium chromate. The chromate chloride is treated with the sodium hydroxide. You are getting the sodium chromate. Sodium chromate. Then sodium chromate is you pour little amount of lead acetate. Sodium chromate, lead acetate. You are getting that lead chromate. This will be yellow precipitate. Precipitate. You can find the precipitate. Here yellow color solution will be available, but the yellow precipitate, you can when you pour a lead acetate solution, you are getting that yellow precipitate. This is the chromate chloride test. Then uses of the end of the potassium dichromate, the uses of potassium dichromate. As you know very well, As I said earlier, qualitative analysis to find the acid radical. In quantitative analysis also it is used. In quantitative analysis to estimate the iron and iodide salt, potassium dichromate is used. Among all, this very important usage of potassium dichromate is a powerful oxidizing agent. It is mostly oxidize most of the organic compound. So it is a powerful oxidizing agent. Other than that, it is used in the dyeing and printing industries. Other than that, we can say this is used in the leather tanning. What is called leather tanning? In order to hardening the leather, the hide, the skin, it will be soft enough. You cannot do any ornaments or any particle from this hide. That is the skin part. You have to tan it. For the turning purpose, potassium dichromate is used. Leather hardening or leather turning purpose also it is used. Thank you. Let us see tomorrow potassium permanganate.